So in this next section here, it's similar to what the past two sections were. Okay, we have some rational expressions, but now we're turning them into equations and inequalities. So you're actually going to solve for that variable, not just simplify. Okay, so equations that contain one or more rational expressions are called rational equations. Okay, so they have an equal sign. These equations are often easier to solve once the fractions are eliminated. You can eliminate the fractions by multiplying each side by the least common denominator. So you're still finding that least common denominator for all of these. So looking for that LCM of all of your denominators. Okay? Except this time we're going to multiply through by that LCM, and it'll cancel out the denominators. So in our example here, we want to solve the equation and then check our solution to make sure it makes sense. So this first one, I have 2 over x plus 3 over 2 plus 19, or equals 19 over 10. Okay, so my first step, step 1, okay, is to find the LCM of the denominator. Okay, so I have all three denominators. I have x plus 3, I have 2, and I have 10. Okay, x plus 3, I can't factor, I can't simplify, so that one will stay as x plus 3. 2 is prime. There's no other numbers that go into it, so that will stay as 2. Now 10, I can factor that one out, so I have 2 times 5 for 10. So now finding that LCM, we'll take our first term here, which is x plus 3. Move on to the second one. I have a 2. Well, I didn't have a 2 yet, so I need to write that one down. Move on to the third. I already wrote down a 2, so I don't need another one. But I'm still missing this 5 here. So I need to multiply by a 5. Okay, so my LCM will be 10 times x plus 3. So I just multiplied that 2 and that 5 together. Okay, next step. Step 2. Okay, is to multiply both sides by the LCM that you just found. Okay, so my LCM right here is 10 times the quantity x plus 3. So I have 10 times x plus 3. I need to multiply each and every fraction by that LCM. Okay, so I'm going to multiply this to 2 over x plus 3. Still adding. I'm going to take that LCM again, so I have 10 times x plus 3, and multiply it to that second fraction, 3 over 2. And I have to multiply it to that last one there. So I have 10 times x plus 3 times 19 over 10. Now the reason we're doing this is to cancel out all of the denominators. Okay, so if I look at this one, I have an x plus 3 and an x plus 3. Those are going to cancel. Over in that next one, I have this 2 and this 10. Now this 10 I'm dividing by 2, so I still have 5 left over there. And then my last one, I have a 10 and a 10. So those ones will cancel out. Now what you'll notice is all three of my denominators are gone. Okay, now I just have to multiply. So I have 10 times 2 for that first one. So that's 20. Plus I have 5 times 3. That's 15. But I also still have this x plus 3 piece. So I need to include that x plus 3. Equals, I still have 19 over here. And x plus 3. Okay, now all we have to do is solve for x. So I still have 20. I'm going to distribute my 15 to both of those terms. So I have plus 15x plus 15 times 3 is 45. I have 19 times x, which is 19x, plus 19 times 3 is 57. Okay, I have 20 and 45 on one side, so I'm going to combine those. So 15x plus 65 equals 19x plus 57. I'm going to subtract 15x from both sides of my equation. So I have 65 is equal to 4x plus 57. Subtract 57. I have 8 is equal to 4x. Divide by 4. And x is 2. Okay, so that was your first two steps. Your last step. So step 3, okay, is to check your solution. So all you have to do to check is plug in 2 for x. So we have 2 over 2 plus 3 plus 3 over 2 equals 19 over 10. Okay, so we have 2 over 5 plus 3 over 2 equals 19 over 10. Now again, we need a common denominator here for 5 and 2. Well, that would be 10. So I need to multiply the numerator and denominator on this one by 2. So I have 4 over 10 plus I need to multiply these two by 5. So I have 15 over 10 equals 19 over 10. Now I can add my numerators. So I have 19 over 10 equals 19 over 10, and that is true. So x will equal 2. Okay, the reason you need to check is because you can't have your denominator equal to 0. Okay, so you always want to check that. Questions on my first one with those 3 steps?
So it equals 0
Then it would be no solution. So if I got x to be equal to -3 in this one, that would make that denominator 0. Right? That would be no solution then. Okay? Or if your fraction doesn't work. Alright, so the next one I have here has polynomials. Okay? So we can factor those and still do the same thing. So multiplying each side of an equation by the least common denominator of rational expressions can yield results that are not solutions of the original equation. These are extraneous solutions. Okay, so if you get to a point where you still have a variable squared, okay, and you have a trinomial that you can factor, okay, you want to factor it and make sure it's set equal to 0, and then both of those pieces you'll set equal to 0. And then you'll get 2 solutions. Okay, one of those solutions might not work, the other might work. Okay, so we're going to see that in this next example here. So again, your first step is to find the LCM of all of your denominators. Okay, so we have step 1. Okay, we want to find the LCM of your denominators. Okay, just like the last time. So with that first denominator there, we just have x plus 5. Okay, that's going to remain x plus 5. I can't factor it. The next one is x squared plus 8x plus 15. Okay, I need to factor this one. Okay, so you can use the x method if you still need to do that. So what multiplies to 15 and adds to 8? 3 and 5. So I have x plus 5 and x plus 3. Okay, and I need that last one as well. That's x plus 3. Can't factor that, so it's just going to remain x plus 3. Okay, so for my LCM, I have my first term there is x plus 5. Move to the second one. I already wrote down an x plus 5, so I don't need another one. But I need this x plus 3 still. Okay, then looking at the third one, I already have an x plus 3, so I don't need another one. So that will be my LCM. Okay, next step, I'm going to write it up here because I think you'll need a lot more room than the last one. So we have step 2. We're multiplying both sides by that LCM you just found. Okay, so taking our first fraction here, we're going to take x plus 5 times x plus 3. Don't write super big. I know for some of you that's difficult, but you're going to multiply that LCM by our first fraction. Okay, so we have 2x over x plus 5. We're subtracting. Again, I need that LCM. So x plus 5 times x plus 3. Okay, we're multiplying by this fraction. Okay, so I'm just going to rewrite this as x squared minus x minus 10. Okay, that's over. I already factored this, so I'm going to write out its factored form. Okay, so that's x plus 5 times x plus 3. Okay, that's equal to, again, taking our LCM, x plus 5, x plus 3, multiplying it by that last fraction there. So we have 3 over x plus 3. Okay, now I can cancel stuff out. So I have an x plus 5 and an x plus 5. I have x plus 5 and x plus 3. Last one, I have x plus 3. Okay, from here, I can multiply. So I have this 2x times, I still have an x plus 3 for this one. This is minus this entire quantity here. Okay, you're subtracting that entire quantity. So x squared minus x minus 10. And all of those canceled. Okay, we have that equal to, I have a 3, and I still have x plus 5 left. Okay, now I can start distributing. So I have 2x times x, that's 2x squared, plus 6x. I need to distribute this subtraction to all 3 of those terms. Okay, that's why I put parentheses around that. Okay, so I'll have minus x squared. I have a negative and a negative, so I'll have plus x, negative and negative, and plus 10. Okay, so I distributed this negative to all 3 of those. Okay, now I have 3x plus 15 left on that side. Okay, now I can combine like terms. Okay, so I have 2x squared minus an x squared. That's just x squared. I have 6x and an x here, so plus 7x. And then I still have plus 10. And that's equal to 3x plus 15. At this point, I still have this x squared term, so I'm going to try and get everything on one side of the equation and set it equal to 0. Okay, so I'm going to subtract 3x from both sides. So we have x squared plus 4x plus 10 equals 15. And I'm going to subtract 15 as well. So we have x squared plus 4x minus 5 equals 0. Okay, so now I want to factor this last one here. So what multiplies to get to negative 5 but adds to be 4? Yes. So I have x plus 5 and x minus 1. That's equal to 0. And if you still need to do the x method, write it out. Okay? Write out the x on the top, what multiplies to be negative 5, on the bottom, what adds to be 4. From here, each of these terms I'm going to set equal to 0. So we're going to take x plus 5 equals 0 and x minus 1 equals 0. Subtract 5, so we have x equals negative 5. Add 1, x is equal to 1. Now these are one of the problems where you do need to check both of your answers. Okay, so again, off to the side here, step 3, okay, check your answer. Okay, so when I have x equals negative 5. Okay, just so I know which one I'm plugging in here. I'm going to plug in that negative 5 to all my terms. So I'll have 2 times negative 5 over negative 5 plus 5 minus negative 5 squared minus negative 5 minus 10. That's over negative 5 squared plus 8 times negative 5 plus 15. And that should equal 3 over negative 5 plus 3. Now before I continue this, what I want you to see right here is that denominator. I have a negative 5 plus a 5. That's going to be 0. Your denominator cannot equal 0. So this answer that you got of negative 5 won't work. So you don't even have to keep going through and solving it. If you see that right away, that answer is an extraneous solution. Okay? And you don't need to remember that it's called an extraneous solution. But that's what it's called. Yeah, so that will, you still have to check 1. Okay, so we'll still have to plug in 1 here. So now when I plug in x is equal to 1, I have 2 times 1 over 1 plus 5 minus 1 squared minus 1 minus 10 over 1 squared plus 8 times 1 plus 15 is equal to 3 over 1 plus 3. Okay, in my denominators I don't see anything where it's going to equal 0 yet. So from here I'm just going to simplify. So I have 2 over 6 minus 1 squared is 1, right? 1 minus 1 is 0. Okay, so I have minus this negative 10 over 1 plus 8 is 9, right? Plus 15, 24. That's equal to 3 over 4. Okay, so I have a minus, negative, thank you. So I have 2 over 6 plus 10 over 24 equals 3 over 4. Now I need a common denominator. That common denominator, we can just make 24 since this one's already 24. Okay, so I'm going to multiply both of these by 4. So we have 8 over 24 plus 10 over 24. Multiply both of these by 6. So we have 18 over 24. And we do get 18 over 24 equals 18 over 24. So that does work, meaning our solution is x equals 1. Does that make sense? What we're doing? Multiplying by the LCM.